So hello, everybody. So I'm going to demo here a tool that is really great for understanding what's going on in the Slurm cluster right now. So the problems with people using our clusters is that Slurm is very verbose. It has a lot of commands to look at what's going on. Some of them have a lot of data that's not really important, and the important data isn't highlighted really easily. So we've created a tool for you that highlights the most important information on the cluster and allows you to easily browse this. So this is our Clusterstats program. I'm going to be doing a live demo as well in this presentation, but there's a little bit of background that I'd like to go through on these slides with you. So the Clusterstats program is very simple. Right now, if you logged into any of our clusters, you could just type Clusterstats and you will get the program that's running. This program uses cached information on the cluster. So what happens is that gathering all this information takes a few minutes, and it's quite intensive on the cluster scheduler. So what we do is we cache this information. So it could be a few minutes old. So if you submitted a new job, it may not show up for a few minutes. But we do refresh this data, at least every 30 minutes on every single cluster in Compute Canada right now. So when you log in the main menu, you'll get a question about information on, and you get user, group, cluster. The user basically contains information on your jobs and your usage of different accounts and groups. The group information contains information on your accounting group and all the other group members that are using that accounting group. And the cluster information contains information on the cluster, the state of partitions, and the nodes on the cluster. So something that's important to note on Compute Canada is that basically we have different types of resources. So we have GPUs that you get allocated by asking for GPUs. And they're basically their own set of nodes. So if you ask for a GPU job, you will run on one of the GPU nodes. You won't run on one of the CPU nodes. If you ask for a CPU cores, but don't ask for GPUs, you will not run on one of the GPU nodes. In addition to that, we have areas set aside for certain users. So if you ask for a whole node, you can run on all the nodes, but if you ask just a single GPU or just a single core, you can run only in the by core or the by GPU partition, only in that subset of nodes. The reason we do this is because if we allowed, like we have large nodes with 48 cores, for instance, and it's very likely that one of those cores would be used by a job if we allow by a single CPU job on there. So it'd be very difficult for users that need whole entire nodes to run on that system. So we set aside some resources for whole nodes, and we set aside, and BiCore has its own smaller partition. However, the binode jobs can run in the, it includes the nodes that are the servers that are in the BiCore partition. Basically, binode includes the resources in the BiCore or the fact that the CPUs are separate from the GPUs, we also set aside the large memory nodes. So the nodes that have more than 12, that have a large amount of memory, and for jobs that require more than 12 gigabytes of RAM per core. So those nodes are set aside. So if you ask for that much memory, you're not running on the regular nodes. You'd be running on those special nodes that have a large amount of memory. And we do that because those are much more expensive nodes and there's much fewer of them. And we'd like to reserve those nodes for the users that need them. So in addition to that policy, we also have a policy with regards to wall time, or how long your job runs. So if your jobs require 0 to 3 hours, it's going to be able to run on all the resources. But if your job basically is 7 days up to 28 days, there's a much smaller number of resources your job can run on. And there's partitions all the way in between. So this is, of course, to allow users that have short jobs to get their response back quickly, and also to have some resources available for users with very long jobs. What's not easily seen here is you can't see, how many resources are available in each of these things, in each of these partitions, queues. And this is what Clusterstats can show you. Not only that, it can show you what type of resources they are. So if you go to the cluster menu, you can select the GPU to get information on GPU nodes, and you could select the CPU high memory for the large memory jobs, and the CPU base for the regular most common type of jobs running on the regular most common servers we have, right? Then you'll get asked, is this, because certain partitions and nodes are reserved for jobs that take whole nodes, you get asked, are you looking for whole nodes? Or are you looking for partial nodes, jobs, right? So if your job requires a whole node, you should look at the whole node section. If your job requires part of a node, you could look at the part of a node section. And then the third part is you'll get asked to see which type of information do you want. Would you like to see the information on the nodes? Or would you like to see information on exactly how many cores or GPUs are available? Or how many cores or GPUs with the memory? Because when you're running a job, you need both CPU core and the memory, right? Or in case of GPUs, you need a GPU, you need a CPU, and you need some system memory. So all those have to be available for a job to start. So with this script, you could see how many are there right now. And after you would do this, you'd get an output like this. This is the table. It shows you the information on all the resources available, right? Here we have the partition, which is GPU base by node, because we've asked for whole nodes of type GPU. And we could see the different types of resources that there are. Along the top here, we could see for how long they are available. So we could see that there's a total of 336 nodes or servers in the 0 to 3 available for 0 to 3 hour users. There's also two servers that are dedicated for interactive usage, for testing and debugging. But we could see when we try to run a longer job, like say 12 to 24 hour, there are only 270 servers in total available. And when we look at, say 7 to 28 days, we could see that there are 60. I think this is on Cedar, actually, quite recently. But we can also see that there are different types of nodes, different types of servers that are available. So we can actually read some of these here. In this section, the P100:4, CPU 24, memory 128,000. That basically means that each node or computer has 4 GPUs of type P100, which 24 CPU cores and 128,000 megabytes of RAM. As we can see here, there are 28 idle GPUs with memory here. They are available at 0 to 3 hour. But if we go to 1 to 3 day, there's no available. So as long as your job asks less than a day, there might be some GPUs available. However, there may be GPUs of other types that are available. In this case, the Volta 100 nodes, there's 36 of them of those GPUs available for 1 to 3 day. We could do the same thing with memory, with the large memory ones. So here is the one, here's the one for Cedar here. Here we are looking at large memory partitions and how many cores with memory are available on them. The nodes with 32 cores and 3 terabyte of RAM, right? There's 96 cores with memory in total, which I think is 4 nodes, right? So 6 of those cores with memory in that partition that allows 3-day-long jobs are available. But if you asked for a 4-day-long job, that would not be idle, right? However, it's possible, so it may be possible to run a 3-day, 6-core, and in this case, the memory share of a 6 cores on that node is 576 gigabyte of memory job. However, we're not actually quite sure whether we can run this, because there may be higher priority job that requested the whole node and is going to be scheduled to run when the current job finishes. So those resources are idle, but they may be reserved for a high priority job that's coming up. But you could see the state of the cluster. You could see how many of the different types of nodes that there are and are available in each of the partitions. And and this will tell you the state and which type of nodes you should be using and running with your jobs. So are there any questions? So here I'm going to run Clusterstats on Cedar. As you can see, we've loaded a cached version. So this is basically what happened on the cluster 10 to 15 minutes ago. I have 2 extra options because I can look at, I'm a staff member, I could look at other users' information and other accounts' information. So here I've selected the information on the cluster. We'd like to get some information on, let's look at regular nodes. And let's look at allowing the partial, by core jobs. So nodes that are available for jobs that, say, ask a single core. And let's look at the nodes information. And here we could see here are how many cores there are, or how many nodes there are. So we could see that in this partition is fairly large. There's 1,646 nodes in total in the 0 to 3 hour queue. But we can see that they're actually distributed between these resources. There's 32 core nodes with 128 megabytes of RAM. There's 567 of them, plus 8 that are available interactively. There's also another 63 nodes with 32 cores and 257,000 megabytes of RAM. And there's 1,016 48 core nodes, each with 192 gigabytes of RAM. So our clusters, they've been upgraded, so they have different size nodes. So if you want to fit your jobs in, you have to understand what nodes there are on the cluster. And also it might be good to understand how many of them are available depending on how long your job is. We could see here how many idle nodes there are. So there's actually 7 nodes with no jobs on them right now. So this could be just nodes that are, in between finishing one job and starting up another one. Maybe the resources need to be gathered for that job to be started. And then we could see as the wall time goes, that the node is allowed to run on increases, the amount of resources available is much less. We could also see some down nodes here. So in clusters with thousands and thousands of servers, there's usually a few that are being fixed. There's probably had a hardware error and need new components. So, we go to our vendor and they're in the midst of being fixed. You can see some downtime here, down nodes as well. We can see the same thing for whole nodes. And we can see that there's actually quite a few more. There's 2,061 nodes in total available if you're running a whole node. That's because we reserved some nodes for whole node jobs so that users can actually make full use of them. And we could look at the same information, but this time we could ask for how many cores there are. And here we could see, and this is cores with memory, but yeah, we could see that there are 66,432 cores total here for 0 to 3 hours in the base systems here. Of that, 17,088 are basically 32 core nodes, and 47,616 have the 48 cores and 192 megabytes of RAM. So you can immediately see how many resources are available by what type, and also for how long you can run jobs in there. The GPU ones, look a tiny bit differently. We could see all the available GPUs. So on Cedar right now, there's 1,272 GPUs for 0 to 3 hour long jobs. Actually 0 to 12, because that's the same number for 3 to 12. But they're all different by the type of nodes there are. So we have 416 GPUs with the type P100, which I think is P100 nodes with 12 gigabytes of GPU RAM. So there's 4 of them on this node with 24 CPU cores and 128 gigabytes of RAM. There's another 112 nodes with the P100 GPU, but this time with 16 gigabytes of RAM. That's what the L stands for. There is also 24 cores, and this time 256 or 257,000 gigabytes of RAM. So depending upon exact size of job you request, you may be limiting yourself to some small subset of these resources, right? If you ask for a V100 L GPU and you ask for 8-day long job, well, there's only 24 of them in total. Out of the 1,272 GPUs, only 24 are available for that type of run. So you have to understand how many resources are there in your job, and you could compare it to what's going on in the system, and try not to pick a number of resources that are in very, very short supply. Especially if you can, if it's arbitrary, if you could change parameters in your program and, make it shorter and checkpoint, for instance. So checkpointing is basically breaking up your program, saving it, and then ending your job, and then having another. When you restart, when you run another job, it basically restarts from the point where you left off, right? Just like playing video games. You save your session, and then you can restart and keep going. So that's a really cool tool for this. Previously, it was a bit difficult.
Hi, Camille. Sorry, there's a question in the chat. So the last question, I answered one question, but there's another question, the last one from Peter. Maybe you can try to answer that. Thank you.
Okay, I can't see the chat.
Yeah, so Peter says, if there are more idle GPUs than idle CPUs, does this mean some of the CPUs cannot be accessed? I'm not quite sure I understand the question because, well, anyway.
Oh.
So you can open the chat you should be able to open the chat, Camille, so it should be in your interface.
Yeah, I got it. Okay, I got it. So the GPU portion of the cluster is scheduled by the number of GPUs that you ask, or at least that's the number of GPUs. So in the GPU portion, we don't really show the CPUs there, or at least we don't. Clusterstats doesn't show how many CPUs are also available, right? It only shows the GPUs that are idle right now. And that's because Clusterstats as right now is a bit complex to understand it's a bit cluttered, it's a bit complex, and we've tried really hard to make it as simple as possible. That's why we have so many menus to drill down to what type of resource you have. So you can't see here how many CPUs are available for the GPU jobs. So remember when I said the CPU, if you ask for just CPUs, you're basically running on a different part of the cluster. If you ask for GPUs, it's a different from the CPU one. So they're not even the same servers that you're running on. Right. So the question, there was a question, how do I know how much time my job is going to take? Well, you would have to run it, but when you start your job, you always have to set the maximum amount of time your job will run, right? That's called the wall time. So you're basically, when you ask for a new job, you're asking for resources. So you're asking for, say, 12 CPU cores, 28 gigabytes of RAM, maybe 1 GPU. And once you ask for that block, you also ask, and I'd like this for up to 12 hours. That's the wall time, right? In that case, then you would end up in the 3 to 12 hour area here. Yeah, but if your job tries to run longer than the maximum wall time you've asked, it will be killed, right? Because those resources are going to be dedicated to somebody else. So you basically have to experiment. Yes, you have to have a rough idea of how long it takes. Yeah. If you have a large number of jobs, you could ask for a much longer wall time and then see. And then when you get the result back, you should then do a correct number of, a more something that uses about that amount of wall time. So you can ask for maybe 7 days for your job to run if you don't know how long. And then it turns out that it finishes in 12 hours or 10 hours, then you should be going into the 12-hour queue for your subsequent jobs, for your next jobs. Yeah. Yeah. And as Alex has mentioned, it's the same for memory. So if you ask for a large amount of memory, well, we have fewer nodes with more memory, right? Like when we look at CPU base, the regular CPUs jobs, there's 85,392 CPUs cores that can run a job with 12 gigabytes of RAM or less. But if you use more than 12 gigabytes of RAM, well, there's only 1,440 here on Cedar. Yeah. So you get a lot of less resources available to you if you ask too much. And what's worse is sometimes there's magic numbers, right? Where there's much less, right? A 7-day-long job here for the large memories, well, there's 544 cores available. But an 8-day-long job, well, there's less than half of that. Because you've just crossed a little bit over. So this table allows you to pick numbers, just inside those ranges if you need to, and make you more productive doing this. So, is there any other questions?
I don't think so at the moment.
Okay. So I'm going to go back to the slides. Okay. So this was the cluster component portion of what you see. We're going to look at your user account and look at your user, your group, and priority components next. And then we'll follow on with stuff about your jobs, bringing all this information together. So there's a question of fairness between groups and users. So here we have a simple example, right? We have a group called Alberta. They've used their share of the cluster is 50%, imaginary cluster, imaginary scenario, but their share of their cluster is 50%, but they've used 70% of the resources so far, right? And that group has users Alice and Albert, and Alice has a share of 50% of the Alberta share, but she's used none of it. Albert has used the entire share there, although sorry, his share is 50%, but he's used 100% of Alberta's resources. And that's 70% of all the resources on the cluster. Here we have another group called Brazil. Their share is also 50%, and they've used 30% of the cluster. And in Brazil, we have Betty and Bob, right? And each of them are supposed to have a share of 50%. But Betty has basically used 2/3 of the group's usage, but that turns out to be 20% of the cluster. And Bob has used 1/3 of the group's usage, which is 30%, which turns out to be 10% of the cluster. So now there's a question. Alice and Betty have jobs in the queue. Whose job should run first? Why? And why is this fair? So Alice hasn't run at all. So some people might think that, Alice jobs should have priority, right, over Betty. But Betty has pointed out that, Alberta has used 70% of the resources, and that group share is only 50%. Brazil has, not gotten its share. So Betty thinks that she should have more priority, right? So we have this, juggling fairness between groups and users question, right? So I can tell you what Compute Canada's answer to this is. So we have to have some answer, right? Whose job goes first? So Compute Canada's answer is the group's usage is always more important. So Betty's job has higher priority because Betty's group, Brazil, has not used their share, but Alberta has used more than their share. So this is done basically by something called the fair share tree algorithm, a big giant jump of words, but that's what we use this. And basically, if there were 4 jobs in the queue, 1 to each user, then the user's job in order would be, well, first of all, Bob, right? Because he's in Brazil, which hasn't used their share. And he's used the least, right? He hasn't used his share within the group. So Bob's jobs would go first. Next would be the other members of Brazil, which would be Betty. Then they would start with the group Alberta, and it would be Alice, who hasn't used her share within the group, and then it will be Albert. So that would be basically the priority from fair share for these 4 users here. So you'll see some of the same headings when you look at the priority for groups here. So when you look at the group menu, you'll be asked actually to select which group. So potentially you can be in multiple groups, right? You could have a rack allocation. Those groups begin with RRG. DEF here are default groups, so groups which don't have a rack allocation. Another type of rack allocation is an RPP, which is like a platform or service, right? And those are basically done via the resource allocation competition process. So every September, there's a call for proposals. The PIs have to write a proposal to get what's it called, resources. It's then evaluated technically. Then it goes to a peer review, scientific peer review, where other researchers are just like and they rank all these jobs, and then we allocate the resources that are available with some function of what was asked for and the scientific score. So that's the RAC process. One thing that is important here is default groups with jobs in the queue are sleeping. They don't get an allocation. So in this case, if I don't have a job in the queue, this is my group, where the account is sleeping here, so it won't show you what the group share is. Also won't show you the fair share numbers because they don't make sense for groups that don't have jobs in the queue, right? Yeah. And here, we could see all this information. So we can see that there's 2 users here. So Camille and Terry Maguire. And we can see that, first of all, the user share of the group, both of us have equal share in the group. Although Camille myself is the only one that has run in this group. So we could see the users in this group, right? A group's cluster usage versus its share is vastly more important to determining the job's priority than the use or share of the individual, right? So this is much more important part here. The group share of the cluster and the group usage of the cluster. But here we can't see the share because there's no jobs here. So if we had a job submitted here, we can see the share that the group has as a percentage of the cluster resources. And we could see how much the group has used in the recent past. Basically, the level of S, that's just how much the group has used in the recent past divided by the group's share. So the group's level of S number here, the higher it is, the better. The higher the priority from fair share you're going to get. And here you could see the individual users. In 4, you could see the individual users' fair share using that account. Yeah. So here's a little bit about the fair share tree, right? How it works. Basically, all the groups get sorted by level of S. And then there is a sort by level FS of the users, like how much the users' usage versus their share in the group. And then we just basically have a list of users and groups, the accounting groups that they're using, and that sets the priority. Basically, it's based upon the ranking in this list. So you'll have a high level of FS if your group has a big share and hasn't used very much. So that gives you higher priority. And then it's the individuals within the group. So biggest takeaway from here is your group's usage and share matters most. Since there's a small number of users within your group and a large number of groups, usage within the group matters the most. Usage with the other group matters the most. Usage within the group matters little, except when your jobs are directly competing with another group member. Yeah, does it show the information of the local cluster that I log into? Yes. So when I demoed Clusterstats, right, that was on Cedar. It directly pulls everything, all its information out of the scheduler. If you logged into Beluga, it would show you the different types of nodes that are on Beluga. I can demo that, showing that as well. So yeah. Oh, since I didn't show the live data, what are the numerical ranges of level of S? Well, level of S is your share divided by usage. So it can be very high number. And I'll show the live data. So here, just for convenience sake, let's go to Beluga. Okay. Let's look at group information. And I'm a member of a number of groups here. So this is live information out of Beluga right now. And as you can see, I haven't had very much runtime in the recent past. You can see CC Debug. I'm part of this group. It's basically Compute Canada staff that can do debugging. See, there's quite a few of us here.
Sorry, Camille, your screen for some reason is not updating, and people are commenting as well. So we just see static image of looks like a terminal, but it's not updating for some reason. So.
Oh, okay. I'm going to stop this here.
Tab.
Maybe you're sharing in wrong window.
Maybe. Okay, yeah, maybe that's why. It didn't like the fact that I changed tabs.
Yes, it works now.
Okay. I also lose the chat every time I do this share. Okay. Okay. So here we run Clusterstats. We look at user info. You can see here my group's usage. By the way, there's a different group usage for CPUs and GPUs because you could get different allocations of CPUs and GPUs, right? Is it still showing Cedar window?
I can see a live window. Yeah, it works for me.
Okay. Okay, good. So here you could see, this research group. I have also access to a group called CC Debug, which is the Compute Canada debug group to run debugging jobs, right? This group doesn't really have a share. There's something special happens where these jobs get automatically have super high priority, but they're basically used for debugging. And you can see all the different users here. So some of the CC Compute Canada staff here, are there. You should see my name right there. And you'll see that, everybody's share is quite small of the whole, the whole this group has basically used very little of the cluster. It's basically just for debugging. And you could see different users that have used the cluster, right? There's about 200 people on this list here, but who is this? This user here has used about 5% of Beluga. Chris Want here has used even smaller percentage. Unfortunately, you can't see very much live stuff. Uh-oh. But Luca's not being very responsive right now. Okay, let's look back at Cedar. I don't know why Beluga is not responding. It's probably a disk thing happening there. Let's get the chat back again. Okay, you guys can see.
Yes, we can see the live window.
Yeah. Do we have a user that will volunteer to show their data here? Because I could look at somebody. If somebody has running jobs, I could show them here. If they have a default accounting group. we as administrators have access to other people's information as well, and all the groups, right? Oh, that are on, well, that are on the system, right? You won't get this option. Let's look at somebody. So here we could see a live group. They get about 1% of the cluster. They've used about 0.14% as a total group. The vast majority of the usage has been that user. And as you can see, their level of FS is 14. So that's quite high because they haven't been using all the resources that they have. And each user's fair share is slightly different. You could see they're quite similar to each other, but users that have used no usage, are slightly ahead of users that have used a lot of usage. So this is how you can tell where most of your priority comes from, right? And you can tell if somebody in your group has been using up all the resources that your group has. When you look at users, you get 2 points here. You could look at your account or your accounts, your groups. And here you get that same information, except you only show stuff for yourself. You don't show other people's. So these are all the groups that I'm part of. So I'm part of Compute Canada Debug CPU, Compute Canada Debug GPU, default Camel AB CPU, default Camel AB GPU, default Camel CPU, default Camel GPU. For some reason, I have 2 roles that are for 2 accounting groups. I'm also part of UCSS 19/WA, which I think was a training allocation at some point. So yeah, these are the groups that I am part of. When you run this, you will get different numbers, right? So any questions? Okay. So as you see here, this is a table for me. But there are multiple. We went into user, then we went into account. However, we could go into the jobs menu. The jobs menu is inside the user menu, and you can actually get information on jobs. So basically, you have a number of options: basic, report, long report, and the output of the scontrol command, scontrol show job, which is diagnostic command. So you can get a lot of information there. So job report, well, it gives you a lot of information about your job. It can tell you who it belongs to, the accounting group. So in this case, user Alice, def Alice CPU. And you can look at the partition it's in or the queue. It's CPU base by core B3, right? Which is the 24-hour queue, I believe. And it'll also show you the nodes that can possibly run your job. So all the nodes that are in CPU base by core B3 and all the different node types and what are their states and whether they are down or idle. And the long report has even more details. Now, it has a little bit more information as well. it says your job is ranked 7,522 of 9,519 in terms of priority on these nodes. So of all the nodes that can run this job, those nodes can run jobs in a few other partitions as well, and all those partitions have 9,519 jobs. When we rank these jobs in order of priority, this job will be 7,522nd. So you can see your priority, but more importantly, your priority relative to all the other jobs that you're running. So if you try to find out the priority of your job on a system, well, you'll see it mixed upon, GPU jobs or high memory jobs. Well, this is just, a regular memory job, right? So you can see your job on all the nodes that it could run on and its level of priority compared to all the other jobs. Right. If it's a running job, it will also show up. But if you hit report, you'll get, this running job belongs to user Alice, accounting group def Alice, in CPU base interact. So this is in an interactive job. So this job was submitted on, have a date. It has run on, there'll be a different time, right? And it has finished, it has run 32 minutes of 3 hours. And you'll get other information such as this job uses 12 CPU cores in one node, one task with 12 cores per task. The minimum number of cores per node is 12, and the minimum memory per node is not recorded, and tells you the resources that this job uses here, and that it's running on Gram 797. Are there any questions?
I have a question about the user interface. I'm not sure if you're already done with the presentation or you still have things to show. No?
I was going to show.
Okay, you're not done yet. Okay, so I'll just wait.
So we could go to user here. I'm just going to pick the top user here, and you could see that there are running jobs here. And you could get some basic information, basically that it's running, its priority, the report here. So in this case, this job, was submitted on March 20th at 10 p.m., 10:31 p.m. It has run for 5 days and 3 hours, right, of 7 days. It uses 48 CPU cores and so on, right? So this is the report. You could get the output of the S-control show job command. It gives you a ton of information about that job. It's used for basically diagnostics. But it'd take a very long time to explain everything that's here. But you could look at the man page for the S-control command for that. And you could select from all the jobs that are running. In here, I have the ability to look at other people. You won't. I'm just trying to find a job that is queued. All these users seem to have. Oh, here we have a job that's failed. And you're not going to get very much information on a failed job. Here we have a job that is pending, which means it's queued. We can get basic information, which gives you that this job is ranked 93 of 4,151 jobs that could run in CPU large bi-core B6. And we could do a report here. So, there are 5 nodes where it can run. And those nodes can run 4,151 other jobs. And this job is ranked 93rd out of all of them. And here are the different types of nodes. So this is a large memory job. It can run on, well, potentially there's the different types of nodes that are available here, right? So there's 3 nodes. Or sorry, there's 5 nodes available total here, right? Of the 2 nodes that have half a terabyte of RAM, 2 nodes that have 1.5 terabytes of RAM, and 1 node that has 3 terabytes of RAM. Terabytes basically 1,000 gigabytes. You can also get a long report. It'll show you all the partitions that can also run on these nodes. So as you can see, the shorter time partitions can also run. So shorter jobs can run in there. But they can also run on other nodes. So we could get quite a bit of information here. So any questions? Yeah. So somebody's asking for a simplified version that would work on their local Slurm installation. Yeah, the main issue is this software has a lot of about how the partitions are set up in Compute Canada in it, right?
Yeah, I kind of figured it was pretty heavily baked into your setup there.
Yeah. Yeah.
I have a few general questions about the interface, if now is the right time to ask. So
Definitely.
Is it possible to use this tool, Clusterstats, non-interactively? So I mean, if somebody wants to, go into a specific report all the time, and this is the stuff they're interested often, is it possible to just bring that part of Clusterstats with the flags non-interactively?
No, so that is not available. There is a test version that will actually get you. So this isn't the one that is available here, but oh, I should probably. Oh, you can see this, right? Or no, you can't, because. So we do have one little option here for staff only right now on a test version. That's, you could select a single user.
All right.
And get that user's information as opposed to looking through the long list.
Okay. Right.
But
Okay,
that's
so
not
the short answer is no, but maybe this is something coming in the future, or maybe not. I don't know. Providing flags in general.
Yeah, if there's a demand for it. And
okay,
yeah.
Sure. So I noticed that in some interactions, you actually get a very long list. So for example, if as staff, I can go into staff accounts and I get a very long list of all accounts. And is it possible to search this list from the GUI?
So it's not possible right now. That would require an updated version of the libraries that I use, which are incompatible with the Ruby install that Compute Canada has right now.
Mhm.
So either the libraries or Compute Canada would have to have environmental changes set up to get it to work.
Okay. Are there any other questions from attendees?